For centuries, diamonds have been revered as some of Earth's most extraordinary treasures, symbols of luxury, power, romance, and even invincibility. Traditionally, they've been known as rare gems formed over billions of years beneath the Earth's crust, extracted through complex and often controversial mining operations. But today, the story of diamonds is being rewritten. Thanks to cutting-edge technology, we can now create diamonds in laboratories that are chemically, physically, and visually identical to those formed in nature. This evolution is shaking up the jewelry industry and opening the door to new scientific breakthroughs. In today's video, we'll answer frequently asked questions like, where do most diamonds come from? How do lab-grown diamonds compare in terms of price, quality, and performance? Can you even tell the difference? And what can these ultra-hard gems do besides sparkle on a ring? Historically, the majority of the world's diamonds have been sourced through mining operations spread across several regions. Africa has long been one of the dominant sources of natural diamonds. Countries like Botswana, South Africa, Angola, and the Democratic Republic of Congo have vast underground reserves, and their economies have been deeply tied to diamond exports for decades. However, concerns over so-called blood diamonds, or conflict diamonds, those mined in war zones and sold to fund armed conflict, have led to international oversight and certification efforts, like the Kimberley process. Russia is another major player. Its diamond industry is led by Alrosa, a state-owned company responsible for producing more than a quarter of the world's natural diamonds. Most of these come from the cold, remote Yakutia region in Siberia. Canada has emerged as a key ethical diamond producer in recent years. They're known for strict environmental standards and transparent supply chains. Canadian diamonds have become increasingly popular with conscious consumers. Australia was once a top supplier too, especially through its Argyle mine, which was famous for rare pink diamonds. But that mine closed in 2020, reducing Australia's output. These natural diamonds form deep in the Earth's mantle, under intense heat and pressure, and were pushed toward the surface through volcanic eruptions. This process takes billions of years, which is part of what makes natural diamonds so prized. Over the past 2 decades, scientists have perfected methods to grow real diamonds in laboratories using 2 main techniques. Using a high-pressure, high-temperature, or HPHT, mimics the natural conditions of diamond formation inside the Earth. A chemical vapor deposition, or CVD, grows diamonds from a gas mixture in a vacuum chamber, layer by layer. Both methods create diamonds that are identical to natural diamonds in terms of composition, structure, and appearance. In fact, even professional jewelers can't distinguish the two without specialized equipment. As of 2024-2025, lab-grown diamonds make up around 15% of the diamond market by value and as much as 30% by volume. That number is increasing fast, especially in countries like the United States, China, and India, where labs can produce large quantities at lower costs. One of the biggest selling points of lab-grown diamonds is the price. On average, they're 40 to 70% cheaper than mined diamonds of the same carat weight, color, clarity, and cut. Let's just say you want a 1-carat diamond ring. A natural diamond of high quality might cost $5,000 to $7,000, but a lab-grown diamond with identical specifications could cost $1,500 to $3,000. This price gap has been growing over time, as lab production becomes more efficient and mining becomes more expensive. For a budget-conscious shopper or people who want a larger stone without the hefty price tag, lab-grown diamonds are a game-changer. To the naked eye and even under a jeweler's loupe, there is no visible difference between a lab-grown and a natural diamond. That's because both types are made of pure carbon arranged in the same crystal structure. Spectroscopy analyzes how the diamond absorbs and reflects light. Lab-grown diamonds have slightly different spectral signatures. An analysis of natural diamonds typically reveals organic-looking inclusions like tiny crystals or clouds. Lab diamonds may have metallic inclusions or growth lines that reflect their artificial origin. Under strong magnification, experts can detect the unique patterns created during the lab growing process. Many diamonds are etched with a microscopic serial number or lab designation on the girdle. That is the thin outer edge, which identifies them clearly. These methods ensure that buyers know what they're getting and can choose with full transparency. Yes, lab-grown diamonds are identical to mined diamonds in every meaningful way. For both, their hardness rate is a perfect 10 on the Mohs scale, making them the hardest naturally occurring material on Earth. They can cut glass, scratch other gemstones, and withstand daily wear and tear. When cut well, lab-grown diamonds have the same brilliant sparkle, reflection, and rainbow dispersion as natural stones. Its color and clarity are graded on the same scale, D to Z for color, and IF to I3 for clarity. You can find flawless lab diamonds or ones with character, just like natural ones. Whether set in an engagement ring or stud earrings, lab-grown diamonds look and perform just like traditional diamonds. While jewelry remains the most visible use for diamonds, lab-grown stones are unlocking entirely new possibilities across science and industry. They are incredibly tough, making them perfect for cutting, grinding, drilling, and polishing. Lab-grown diamonds are now replacing natural ones in saw blades, dental tools, machining equipment, and more. They have exceptional thermal conductivity and can act as semiconductors, which is useful in electronics that generate a lot of heat. Diamonds with specific atomic flaws, known as nitrogen vacancy or NV centers, are being used in quantum sensors and ultra-precise magnetic and temperature detection systems. Those same NV centers are being explored for applications in high-resolution imaging and non-invasive diagnostics. In the near future, diamonds could help us build faster computers, diagnose diseases more accurately, and even explore space with more durable equipment. Diamonds have come a long way, from rare geological marvels mined from deep within the Earth, to advanced lab-grown crystals pushing the boundaries of science and style. While natural diamonds still hold strong emotional and cultural value, lab-grown diamonds are redefining the industry with their affordability, sustainability, and technological potential. Whether you're shopping for jewelry or building next-gen tech, diamonds are no longer just a symbol of the past, they're a glimpse into the future. And in that future, they're just as brilliant, maybe even more. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.